Today in this video, I'm going to be explaining the wildcard mask. And I am Seth Souza, or CCNP Seth. So the wildcard mask, this can be used with routing protocols, with the network statement, and also with access control lists. And wildcard masks are used in lots of different ways, but do we really know what's going on? So you have to look at it at the bit level. So this is how I'm going to explain it. Alright, so let's get to the next slide. And two simple rules for the wildcard mask. 0 bits in the wildcard mask must match the corresponding IP address bit. Okay, when you see zeros in the wildcard mask, that means corresponding bit in the IP address has to match. Ones in the wildcard mask do not care what the corresponding IP address bit is. Alright, so that's like the technical explanation of it, but I'm going to show you an example. Alright, so here's a standard access list line. IP access list or access list 1 permit 10.1.10.1 with the wildcard mask of 0.0.0.0. So what does that mean? Wrote it out in binary. This is what 10.1.10.1 looks like. So with the wildcard mask being all zeros, we can see that all zeros, the corresponding bit must match. So this must match, so on and so forth. So when you apply this access list, this wildcard mask means I'm only allowing this IP address through. That is it. No other IP addresses. So that's what the zeros mean. Let's take a look at another example. We got access list 1 permit 10.1.10.1 with a 0.0.0.3. Alright, break that down into bits. And we can see here all zeros must match, so that means we are gonna allow 10 in the first octet, all zeros in the second octet, so that means 1. And then all zeros in the third octet, so that means 10 again. But now we see some 1s in the wildcard mask. So this is what it actually means. These bits have to stay the same, alright, because they're all zeros. But now look, we get to 1s. 1s in the wildcard mask, they don't care what the corresponding IP address bit is. So just because this is 0, 1, that doesn't matter. It doesn't care. It just makes sure when an IP address comes through that these bits match. So these two bits, it doesn't matter. So we could have a combination of 0, 0. We could have a combination of 0, 1. Let's see what else. 1, 0 and 1, 1. Now, what this means, I should probably choose a different color. Let's choose black now. So what this means is I'm allowing 4 different combinations of an IP address to go through based on what the wildcard mask is and the corresponding bits to the IP address. So what is 0, 0 in the far right bits of an IP address? That just makes it a 0. 0, 1, a 1, a 1, 0 equals 2, and a 1, 1 equals 3. So that means this access list, I am permitting IP addresses 10.1.1.0, 10.1.10.1, 10.1.10.2, and 3, so on and so forth. So that being said, that's like the basic understanding of the wildcard mask and how it corresponds to the IP address. Some people just think, just use the opposite of the subnet mask. You know, you could have like, what is it, 255, well, that's not it. Take that off. What is it, 255 and then minus the the subnet mask. So let's say the subnet mask of a certain octet is 224. So this is how you would get the wildcard mask if you did this approach. The 255 minus the wildcard mask, that'll give you the equivalent wildcard mask there. Was I saying that right? Wildcard mask? subnet mask. Okay, this is how you find the wildcard mask. You use the subnet mask and you subtract it from 255. So how do we do this? Let's see, 255 minus 224, that becomes 1, that becomes a 3, and that becomes a 0. So you can see like a wildcard mask. So let me clear this up. If we had a wildcard mask of 0.0031, then that means the corresponding bits, the first 3 octets have to match. So that is what, 10.1.10. something, and then we draw out 31 bits, which, what is that? Does that look right? Because 128, 64, 32, nope, one more. So these 5 bits. So what are all the possible combinations? Well, that actually turns out to become 0 through 31, things like that. So it's incorporating 32 different IP addresses, and if we were to apply 31 here, then it would allow 0 through 31. But that's how people find the wildcard mask. They use the subnet mask and then have 255 and then subtract that one portion. Hope that didn't confuse you too much. I hope my first example right here clarified it for you. But just remember the rules of the wildcard mask. 0 bits in the wildcard mask must match the corresponding IP address bit. 1s in the wildcard mask, they don't care what the corresponding bit is. It could be on or off. It could be a 0, 1. I don't care. That's why this allows more IP addresses. So that is it. I hope this was informative for you, and I'd like to thank you for viewing.